are going to learn about probability. A sample space is a set of elements, set whose elements represent all the possible outcomes. So if you're flipping a coin, what is a sample space? What's a sample space if you're flipping a coin? Not how many in the sample space. Heads or tails, right? It's what can occur. Usually it won't land on the side. The measure of how likely, so 2, the measure of how likely it is that some of them will occur, a number expressing the ratio of favorable cases to the whole number. This is actually the probability. So sample space is what things could happen, and the probability is the likelihood that one of those things will happen, okay? And this just says, you don't really have to know this formula, except that the probability is always, can never be bigger than 1, and it always has to add up to 1, right? So for instance, if it's going to rain, what's the probability that it will rain today? I don't know, maybe 10%. What's the probability that it won't rain today? 90%. Those two things always have to add up to 1. And so when you add up all the different probabilities, they need to add up to 1. So in a bag of M&Ms, the candies are red, green, blue, brown, yellow, and orange. Therefore, the sample space is that which of the following are probability models. And so you would just look at that and see which of these add up to 1. So does this add up to 1? 0.45. Yes, so this one works. I don't think you could have a negative probability, so you could throw away this one, right? Because it's got a negative in there. And then what else? Does this one add up to 1? 0.3, 0.7, up. That one you got to throw away because it adds up to more than 1. And this one, is this a probability model? Yes. It has lots of yellows in the back, right? Do they even have, they have yellow M&Ms? They do? I didn't ever see. And this is a picture of a number cube. Because you're not allowed to say dice in class because that implies gambling, which you're not allowed to talk about. Okay? What I don't understand, an experiment consists of rolling a fair die, construct a probability for this model. Okay, so the sample space is just going to be what can happen on a dice, which is you can get a 1, a 2, a 3, a 4, a 5. Oh, I wasn't supposed to say dice. Number cube. List the probability. So what's the probability? For instance, we don't have to list the probability of each outcome. What's the probability of getting a 2? 1 out of 6, etc., etc. Okay? So you could, I'm not going to list them all. That's too much. Find the probability of each outcome if only a 3 or 4 could occur, and a 4 is twice as likely to occur as a 3. So this could be a little bit tricky, because what's a sample space? You can only get a 3 or a 4. That's sample space. So what you could do is the probability of getting a 3 is going to be, we'll call this x. And the probability, this is the easiest way to do it, I think, rather than try to do it in your head. So the probability of getting a 3 is x. What would be the probability of getting a 4 if it's twice as likely? 2x. Okay? Now, what do you know about x plus 2x? They add up to 3x, but what do those two have to add up to? 1, right? 3x equals 1. See that? Okay? Therefore, the probability, I'm jumping up here, probability of getting a 3 is x, which is 1 divided by 3, which is 1/3. And the probability of getting a 4 is 2x. Since if I solve this little equation here, right, I get x equals 1/3, right? X equals 1/3. So probability of getting a 4 is 2x, which is 2/3. Do those two numbers add up to 1? Is this twice as likely as this is to occur? Yes. Okay, so that's how they do that. Okay, moving on. An experiment consists of tossing by the coin is weighted, so this is kind of the same thing. Lists the sample space. An experiment of tossing coin. An experiment of tossing a coin. So you would do this kind of the same way, okay? Sample space is still heads or tails, right? Lists the probability of each outcome. Well, the probability of getting the coin is weighted so that heads is 3 times. So the probability of getting the tails is going to be x, and the probability of getting heads is 3x, right? 3x. 3x. And you know that x plus 3x has to add up to 1. So 4x equals 1. So x equals 1/4, right? So what's the probability of getting a tails? 1/4 or 25%. And the probability of getting a heads is 3/4 or 75%. Questions on how to do that? Kind of the same problem, okay? So probability is defined as the number of ways that an event can occur over the number of all possibilities, okay? Calculate that in a 3-child family, there are 2 boys and 1 girl. Assume equally likely outcomes. This answer might surprise you. Anyone know? What? What? 1/8. No. Who wants to make a guess? 2 boys and 1 girl. 2 boys and 1 girl. Who has 2 boys and 1 girl in their family? Anyone? No? Is it 1/4? No? So the way you'd have to do it is make a little, you could do a tree diagram. So the first kid, so here's kid number 1, right? You could have, so mom could have a boy or a girl, right? Okay, here's kid number 2, yes? So if they have a boy, then the second time they could have a boy and a girl. Or over here, they could have a boy and a girl, right? So here's kid number 3, yes? So you could have boy, girl. You could have boy, girl. You could have boy, girl. Or you could have boy, girl.
What if they have twins?
Well, don't make things complicated, okay? So how many different outcomes are there altogether? 8 different things, right? 2 times 2 times 2. So there's 8 different possible things that could occur. Out of those 8, how many are 2 boys and 1 girl? Hello? 3, right? There's 1, right? Boy, boy, girl. Here's another one, boy, girl, boy. There's another one, girl, boy, boy. So there's 3 out of 8, right? Now another way, the way I kind of figure that out, sometimes it's good to work backwards. What's the possibility of getting 3 boys? How many of these paths lead to 3 boys? 1 out of 8. What's the possibility of getting 3 girls? 1 out of 8, right? So that would make 2 out of 8. So the other ones must comprise 6 out of 8. So I guess, well, if half of those 6 out of 8 would be 2 boys and a girl, then the other half would be 2 girls and a boy, right? So that's the way you can think about that one. So 3 out of 8. What's the probability of getting, so here's what happened in my family. We had 4 boys. And then my brother, who had kids, row. 2 to the 8th power, which is a big number, right? One out of some, like lots of thousands. So, anyway. Okay, moving on. Consider the experiment of rolling a single fair die. Let E represent the roll an odd number and let F represent roller 1 or 2. Write the even E and F. What? E and F? Oh, I think that should say the probability. Write the probability of getting an even and an F. An even and a, what's F? Let F represent the event or roll 1 or 2. So what is the probability that if you roll a die, okay, it is both even and it is a 1 or 2? Is it 1 out of 6? Yes. 1. What's the probability that it's an even? 1 half. What? So you guys say it's 1/6. The way you can do that is you can multiply. If it says and, you can multiply the probabilities. Okay. So what's the probability of getting an even? Hello. Probability to get even? Probability to get an even? 1/2, right? What's the probability of getting a 1 or 2? 1/3, right? And so what's 1/2 times 1/3? 1/6. Okay? So that's the probability that that number is. Oh, that's this one.
Yeah.
Whoops.
It's supposed to say event.
Write the event E. Oh, write the event E and the event F. Compute E or F. How would I do that? You would add them. Okay, so that would be 1/2 plus 1/3. Okay, because you have a 1. Wait, not quite. Because sometimes you have an overlap, right? 1/2 plus 1/3, and sometimes it's double. So you'd have to subtract 1/6. That's what this formula says right here. The probability of event E or event F is the probability of E plus the probability of F minus the probability of the intersection. It's just like the set stuff. So 1/2 plus 1/3, you got to be kind of good with fractions. This is 3/6, and that's 2/6. Yes. So you would get 3/6 plus 2/6 would be 5/6 minus the intersection, which is 1/6, and 5/6 minus 1/6 makes 4/6, which is 2/3. Yes? Hello? Questions? Oh, I think I was going out of order, right? Event E or F would be 1/2 plus 1/3, okay? E and F would be 1/6, right? And write the event. It's not the probability. E or F. Okay, I kind of messed up. But you understand that this is that this would be compute PE and PF. I went way out of order. But do you guys understand what I did there? You have to take each one individually and subtract the intersection. Okay? So for this one, all you'd have to do for this probability of event D is 0.2. The probability of event F is 0.3. And the probability that both things happen is 0.1. So minus 0.1. So you get 0.4. If they are mutually exclusive, meaning they can only happen independently, right? like say a 3 or a 7, 3 or a 7, 3 or 7, you can get a 7, 3 or a 5, or a 2 or a 6, right? Then you just add those two probabilities together. So if you had like a 3 or 5, the probability would be 2 out of 6, or 1/3. And the probability of a 2 or a 6 would also be 1/3. And you add those two together, and you get 2/3, not 2/6, okay? For the probability of getting a 3 or 5, or a 2 or a 6. Yeah? No? Maybe? Okay, and that's what it means to be mutually exclusive. So in this case, it'd just be 0.4 plus 0.25, or 0.65. Okay? And last couple things. The probability of a complementary event, that's this thing with a bar on the top, is 1 minus. Okay, so for instance, like that little example that I gave you at the beginning, on the local news it says that the chance of rain is 40%. What is the probability that it will not rain? 1 minus 60.6, or 1 minus 0.4, right? 1 minus 0.4, which is 0.6, which is 60%. Okay? Now this could be very useful. How many think that there are people with the same birthdays in this class? What do you think the likelihood that there would be 2 people with exactly the same birthdays in this class? Not very good? I would be willing to bet that there are 2 people with the same birthdays in this class. How many people are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's see. How many people were born in January? Just 1. I guess that doesn't work. February. Okay. Dates. 8? 9? 5th? 24th. March. 8. Doesn't work. Anyone else? Any matches yet? Ah! We got the same birthday. Hey, we should celebrate. Party. Okay? So we just found 2. We only went through 3 months. The reason for that, okay, is so this is kind of like this problem, but more complicated. The probability, okay, the probability of, the way you would figure that out is the probability that people do not have the same birthday would be 365. The probability of not having the same birthday would be 365 permutation, however many people are in the class. How many people are in the class? 4, 8, 12, 15, 19, 23, 27, 28, including myself. So that would be 365 permutation 28, okay? What is it, and out of how many altogether? How many different, if everyone could choose one particular birthday, what would that be? 365 times what? 365 raised to the, it wouldn't be 365 to the 28, would it? It'd be 365, yeah, it would. Wait, let me look at my notes. Let me pause. You would have 365 raised to the 28th power, okay? Because you could have birthday on 365 days of the year, you could have 365 birthdays on the year. So if I do that on my calculator, okay, and I go 365 math permutation 28 divided by 365 raised to the 28th I get I get like 0.35 or 35%. Okay? So this number is actually 0.35. So what is the probability that two people will have the same birthday? 1 minus 0.35. So the probability that two people in a class of 28 people is 65% will have the same birthday. You understand why that is? Okay?